So I'm going to talk for a moment about radicals and signs. And when we talk about radicals and signs, there's a couple important things to note. Uh, you can take the square root of any positive number. So you can take the square root of anything positive. So if x is greater than or equal to 0, we're okay. Then our answer is real. I cannot, however, if I've got a negative number under there, under the radical, then our answer is not real. So if it's positive, it's real. And that means I could say, oh, square root of 16, oh yeah, this is 4, which is, guess what? It's real. If I say, oh, square root of negative 16, not real. Oops, sorry, that's supposed to be a negative. Negative 16. Square root of negative 16, not real. Now, this is not the same as doing the opposite of the square root of 16. Notice that the number under the radical, this is the one that needs to be positive. This is just going to be the opposite of 4, which is, of course, just negative 4. So as long as what we have under a radical, a square root, I should say, is positive, we're going to have a real root. And this is, of course, in fact, the root of this radical is 4, and then we just took the opposite sign of that. Now what's really interesting is this rule only applies to radicals with even roots. So now I'm going to add something up here. I'll say n is our index, and I say that n is even. As long as we're dealing with an even root, which means that n is 2, 4, 6, 8, or so on. I don't really want to think too hard about like 10th roots, 12th roots, or 44th roots, but I know the same rule applies. As long as I've got a positive number over here or under that radical, then my number is real. Now, the next thing, though, is what happens with our odd roots. Well, if the index is odd, then all of the roots are real. And they're going to match the same sign. So say I've got the cube root of 8. Oh, that's just 2. Cube root of negative 8. Oh, that's just negative 2. And if we think about that, this is because, and I'm going to use a symbol here that you might not be familiar with, 3 dots in this configuration means because, and if it were 1 dot up, it means therefore. This is because negative 2 to the third power is equal to negative 8. Negative 2 times negative 2 times negative 2 is equal to negative 8. I could even take this a couple steps further. I could say the fifth root of 243 is 3. The fifth root of negative 243 is negative 3. That's because 3 to the 5th power is equal to 243. And yeah, I'm a geek. I know that off the top of my head. It's okay. With enough practice, you can be this level of geek too. Now, this is a lot of how radicals work with signs. The same rules are going to apply to our rational exponents. So the same thing is going to happen with our rational exponents. If your denominator is even, then your base, which in this case is going to be anything inside that set of parentheses, must be positive in order to give us a real root. So say I've got, say I said I've got 8 to the 1/2 power. I can do that. This would give me a real number. I don't know what that's going to be, but I could say, oh yeah, that's going to be real. If I've got -8 to the 1/2 power, that is not real. Now, some folks who are paying attention might be realizing, oh yeah, I'm using real and not real, and I'm using these words fairly consistently. Yes, there is such a thing as numbers that are not real. There are a set of numbers that are in fact imaginary. And that's a property of numbers, whether they are real or imaginary. And that's something that we will get to at a later date. But funny thing is, if I could take this, but be careful where, like I say, with this, it all depends on, when you're paying attention to this, it all depends on what the base is. Here, the base is positive. Here, the base is negative. If I've got a -8 to the 1/2, remember, exponents only apply to what they touch. This, an equivalent statement to this, is -1 times 8 to the 1/2. This would just be negative, well, square root of 8, which we could simplify to -2 squares of 2. So when you're doing that, make sure you pay attention to where there is a negative. Exponents only apply to what they touch. So if you see a negative, and it's not inside a set of parentheses or under a radical, it's not part of the base. Alrighty, that's all I've got for right now.